All right, this is Calculus 5.2. We're on example 6, and I know it does say extension, but we're going to do it anyways. The College Board loves these type of problems where you have to solve for k. So you're going to see something like this on the multiple choice somewhere, and some maybe even on the free response. So let g be a function given by g of x equals x squared times e to the kx, where k is a constant. For what value of k does g have a critical point at x equals 2 or x equals 3? I have critical point. We see that. We know that the derivative equals 0. So I got to find the derivative, set it equal to 0. Looking at this function here, I've got a lot going on. I have a product rule. So I've got the red, I've got the green. Notice inside the green here, I've got a chain rule going on. Okay, so I've got to deal with that too. All right, so let's start taking our derivative carefully. So g prime of x equals, I'm going to start with the derivative of my red, which is x squared. Sorry, it's not x squared. It's 2x. 2x. And then I leave my green alone. So e to the kx. K is going to act like a number. So we're going to pretend it's a number. Then we've got a plus sign. Then we've got to take the derivative of x squared. Or sorry, keep the red. Sorry, so it's just x. And then we've got to do the derivative of this green. Let's do that off to the side. So I'm just going to call it f of something. F equals e to the kx. All right, we know that we've got a chain rule present, so your u part of the chain rule is going to be kx, which means that du is equal to just k, because k is acting like a number. It's acting like a 3. All right, so we're going to, and then we're going to go back to our original here, and we're going to go e to the u and take the derivative of that. Derivative of our outer function e to the u is e to the u. And then multiply that by the derivative of the inside that we got, which was just k. And then I'm going to plop my u back into this. So k e to the kx. So that's going in as my derivative of the green. So k, which I'm going to throw out in front here, e to the kx. Now, we know that in order to get critical numbers, we set our derivative equal to 0. Perfect. Okay, let's go back and read this a little bit more. It wants me to find the value of k when x equals 3 halves. That sounds like we need to plug 3 halves in for x. So let's do that. So we've got 2 times 3 halves e. I'm going to write it as 3 halves in for the x times k plus k times 3 halves squared e. Again, I'm going to go 3 halves times k equals 0. All right, let's see if we can simplify this a little bit. I'm seeing that the 2's cancel, so I've got 3e to the 3 halves k plus 3 halves squared would be 9/4 k e to the 3 halves k equals 0. Now I'm equal to 0. It means I could probably factor a little bit. I am noticing a greatest common factor. I'm going to take that out. So I have the greatest common factor of e to the 3 halves k. When I take that out, I'm left with 3 plus 9/4 k. What do you know? I could do zero product property on that. So I'm going to go e to the 3 halves k equals 0. And 3 plus 9/4 k equals 0. Now, the only way to get rid of an e is to natural log both sides. Unfortunately, we can't take the natural log of 0. It doesn't exist. So this over here produces no solution on this side here. However, we can get a solution off the other side. So I'm going to subtract my 3 to the other side. And then I'm going to multiply by the reciprocal. So I'm multiplying by 4/9. All right, so 3 goes into 9 3 times. My k value is -4/3, and what do you know? That's one of my answer choices.